Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So you said you had been listening to or talking to John DeGose?
Oh, it was just a talk.
It was a
that I
talk
was
that he gave.
watching, about
Yeah.
Scala 3, but
Uh-huh.
he brought up a topic in there that kind of blew my mind. I've definitely drank the Kool-Aid of static typing and think
Really,
that,
you think?
think that everything should be statically typed. The more static typing, the more compiler validation, the better. But he kind of offered a different perspective for me, which was that there's a lot of times in static type systems, we actually are building something that then doesn't actually get validated until we run it against the system. So some examples of this are SQL is a great one. I really like writing my SQL code in a statically typed language. So instead of writing SQL, which is just full on dynamic, and then passing that SQL query over to the system that then runs it, I really like to use these libraries that give me static types that then compile into the SQL that then get run. Because if you're talking to a database, then SQL is the only language that it understands. So I have really enjoyed that experience, but I'm also that static programming bigot, and so of course I would like that experience. So what John was saying was that I get some benefit of the static typing when I do that. I can have some amount of validation, but I actually get zero validation that the thing is actually going to work until I actually run it. Because I don't know if that SQL statement is actually valid, that the one that has been created by the static types, I don't know if it's actually valid until I actually run it against a database. And that's just one example of many different places where we do this. And what John was saying is that he understands why people are so drawn to dynamically typed languages, specifically for things that are mostly unable to be validated until runtime anyways. So this could be reading JSON, taking a JSON request and doing something with it. Like you don't know until you actually get that JSON if your code is valid and going to work. SQL, things like data science-y stuff with Spark, which again is just, you really don't know if it's going to work until you run it. And so it's interesting to see it from that perspective of like, oh, I really think everything should be statically typed. But at the end of the day, I don't know if all the static typing that I'm doing is actually giving me much value.
The analogy that I would use is like pure math versus applied math. Because yes, pure math, when you prove something, it's like, yes, this is a universal proof. But there's only so much you can do with that. And whereas applied math, you're going, okay, we're going to see if this works or not. And if it does, yay. If it doesn't, we'll futz around with it. And it's very kind of fungible, changeable. I was having yesterday, I talked to Luciano Ramallo, who's the author of Fluent Python, and he's working on a second edition now. And he made the comment, he said, statically typed languages prevent you from, how did he put it, writing code that you know will work, but to jump through the hoops in order to make it statically checked, it can just be really painful. And the experience that I've had with Java generics has been like that, where you go, I know what I'm trying to do here, but to get the generic signatures right is often actually it reminds me of darn, what are the regular expressions?
Oh yeah.
It's like I can do a certain number of things with regular expressions, and I usually, if it gets bigger than that, I break it into multiple ones so that I can understand each one. But there are people who can like just go, oh, just do a back this or a forward back references and things like that, and it's just like, I don't know. It feels like it's beyond my mental ability to do that. And it's the same with generics. Maybe this is what
I mean. I've seen people do this with SQL too. People will just come out with some SQL statement that I'm like, whoa, like
I can't
that's,
understand that.
yeah.
And it's like, I mean, it's great that somebody can do that, but everybody's got to understand it. And so Luciano was saying, here's this piece of code. Now I know I can get it to work, and I have tests for it, which are not static checks. There are other kinds of tests, but a compiler that is requiring me to fit everything into that box, it won't let me do it.
Mm-hmm.
And so I wonder, where is the proper place for that line? If you're going to say, because my experience with Java feels like it's just it's when when the language designers ran out of gas, they go, oh well, we'll just make this dynamic, and you have to do a cast, and you'll have to put in ignore this warning on it, and so it's possible to do it, but the thing is, it's kind of discouraging, to it's like telling you, no, you're doing it wrong, but I'll let you.
Yeah. Yeah.
And maybe it should be something like, no, we have this clear distinction where here's all the things that you can do statically, and we're going to do those awesomely. And then when you want to do something like this, here's a flag for you to set. And then if you're having trouble with your code, maybe you should go look at those things first, because that's, a likely, I don't know. But it's a fascinating. I also realized that for so many years I've been defending Python's dynamic typing, and I didn't really know why. It's just, hey, this works for me. But I think John DeGoe's his observation, which is that sometimes if you're going to do stuff statically, you want it to all happen there. And you don't want to be going back and forth between the two. Oh, I've got the static checking. Okay. And now I've got this dynamic stuff. With Python, it's like, well, you're going to find out about it at runtime, except for the optional static typing stuff now.
Yeah. 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 I mean, ActionScript 3 was interesting in this respect because it allowed you to, at the class level, say if you wanted something to be dynamic.
I think at the function level too, wasn't it?
I think it's only on a class.
Oh, was it on a class?
Yeah.
Okay.
Yeah. So if you had a class that extends object, then that became a dynamic class, and so you could do whatever you want to against that instances of that class. There was no static type checking on any calls or property references on that class, but otherwise you were statically typed, and it was really interesting because there were. It did sometimes feel a little, you would feel a little bad if you went into the dynamic land, but if you're interacting with a system that you can't validate anyways, like you've made a HTTP request to some service and you've gotten a response back, like you can't actually validate that until you make that call anyways. So making those kinds of things dynamic didn't feel that bad and actually made you a lot more productive, because you're like, I don't have to model this thing with no guarantees of until I run it that the way that I've modeled it is actually accurate to what the thing is. So you just make it dynamic and you'd run it and verify.
And you do tests on it.
Yeah.
It wasn't like you would just go, naturally this works.
Right.
It's just a different kind of testing.
Yeah.
I wonder, this idea, I think, kind of crept into checked exceptions as well, because that's, a kind of a static checking. And in the end, it's like, well, the point of exceptions is recovery. Took me a long time to realize that. And most things you can't recover from. It's only if you're crossing boundaries, you're talking to an external system that might fail. And then if it does fail, maybe you can just try it again. That's almost the extent of most recovery. It's like, how much else can you fix? And everything else is basically programmer errors. And so having checked exceptions to, imposed on you for that very small situation, and using exceptions everywhere for that matter.
Yeah.
And it's taken so long for me to kind of get clear on it too.
Yeah. Yeah.
I think it's a fundamental mindset of whether we can control everything.
Yeah. Yeah. And I want to control everything.
Sure.
But anytime I talk to an external system that has a data model that I don't have, I can't control that, right? Like it is a piece of my system that is out of my control in terms of what's going to happen.
Yeah, even in functional programming, that's, we've been able to like fit everything over here. It's like, okay, here's the pure math stuff that I have control over, and then if I cross a boundary to the outside world,
To the outside world, yeah,
or even to, well, I guess a clock is the outside world,
yeah,
the passage of time.
Yeah.
Any of that stuff, it's like, well, I don't know what's going to happen with
Yeah.
that. That's where all the problems are.
Yeah.
So
Yeah, so in the example of when I'm writing like Scala code or Kotlin code against a service that I'm consuming data from, I think this is a good example. What I do is I have a basic idea of what the data model for that service is, and so I try to model that data into my static types. And the only way that I can actually validate if my model that I've created is accurate is to actually call that service and test, okay, is the thing that I got back from that actually fit into my model or not? And so when I'm actually iterating on these types of things, the same thing is true for when I'm writing SQL statements, right? It's like I'm constantly actually iterating in my development cycle to try to verify that my model matches the external model. And so I'm already like running against the external system to do this validation. But I'm trying to get my statically typed model to conformance with that external system. And the dynamic typing model just says, all right, you're already like running this thing to validate your model. Why don't you just run the thing and validate that your code actually works? The thing actually runs.
That was my argument with Python, was that we still have to do tests.
Yeah.
These tests just happen to be there. Static tests happen to be, the Python actually does have a compile phase. But anyway, it's like they're all tests to validate whether your system is okay. And to say that you can only have static tests might be too limiting for a practical system.
Yeah.
I don't know.
Yeah, I mean, if you're talking to an external system, you need to have integration tests that validate that things are actually going to work. And
because that external system could change too.
Yeah, that's a whole nother thing is how do you handle potential change? But even just to validate that as things are right now, that they actually work, you should have integration tests. And I write a lot of integration tests. Most of the code that I write ends up needing an integration test because I'm actually talking to an external system and need to validate that in some way. I've been using test containers, as I've talked about a bit on this podcast, as a way to easily set up some external systems and validate them. So test containers take Docker containers and plug them into the testing cycle or your local development cycle. And so that if I need a Postgres database with a schema, I can at least like bootstrap that as part of my test and run my integration test against that and validate that it works as part of my tests. So it just creates a nice way to do those external validations. But my compiler is not telling me that my query is invalid or my schema mapping is invalid. It can't tell me that, right? There's no way for the static type system to actually tell me that.
I wonder if this isn't like an extension of Gödel's incompleteness theorem, where it's like, basically there's only so, I mean, you can have a complete model of your system, but there's always a boundary and an outside to that system. It can never encompass everything.
Yeah.
Or at least that's my take on the incompleteness theorem. And it's like, this feels kind of like that.
Yeah.
It just popped into my head. I had an insight about concurrency, which was that all any concurrent system that's actually going to run faster than a regular system has to have parallelism involved. Because if you think about it, even, because we have an async system, which is like, for example, in Python, you're running, a single task to run everything. And it only makes sense if you're, calling out to an external system, which has its own processor.
Yeah.
But if it's all packaged inside, then you're going to have, unless you're using multiple processors within your machine, if you've got a single processor and you're running an async thing, it's going to cost more because of context switching.
Right. Yep.
That was just a side thought.
Yeah. Yeah, I like it.
Mm-hmm.
Yeah. It's relates to something I used to talk about a long time ago with reactive. When we first started talking about reactive stuff, I said, if you don't have anything to not block on, then reactive has really almost no value for you.
Mm-hmm.
You need to be able to do things in parallel, essentially, to relate it to what you just said. And if you can't do things in parallel, then there's not value there.
So. Yeah, if you don't have those other processors running.
Yeah.
But reactive is really another form of concurrency, right?
Yeah, it's a way to take advantage of concurrency for mostly IO things. So
right.
A lot of times in IO you're waiting.
Sure.
And
might as well do something else.
Might as well do something else. Exactly.
Other processors coming up with its data. Yeah.
Yeah. For something IO wise to respond.
Right. And if it's an internal system, then it doesn't make sense unless you have multiple cores in your CPU that can be running these other tasks.
Yeah.
So.
Yeah. Yeah. So the dynamic static thing, it's, I think John's framing really helped me understand a lot of the pushback against trying to do everything statically. And I get it. And I just wonder if we haven't really found a good kind of middle ground to this yet. So with protobufs, I think we're starting to see the ability to do this a little bit differently in a way that may actually be a step forward into making it so you can actually validate external systems at compile time. So with protobufs,
because now are you making a distinction between protobufs and gRPC? Because I think of protobufs as a mechanism to implement gRPC.
Yeah, so let's talk first about protobufs. So with protobufs, there's the IDL. What's that stand for again? You introduced me.
Interface Description Language. So it's like a generic programming language that gets compiled into specific programming languages.
Yeah.
So you're able to say, and it's just interface. It's basically just interfaces.
Yeah.
And then when you compile it into, say, C or Python or whatever, there's ideal compilers for basically everything.
Yeah.
It generates the actual code that you need for the Python to send and receive, or whatever.
Yeah, and so the IDL for gRPC and protobufs is the protobuf description, and then there's the proto-C compiler that takes that description and then can generate many different languages, wrappers around that description. And so then gRPC is the communication protocol that then uses protobufs underneath the covers to actually communicate. But with gRPC, you have a server that says, I talk this protocol, and you have a client that then talks that protocol. And so you've got this agreed upon contract where you've generated both the server code and the client code from a shared IDL.
Right.
And so now you have an external system that you're talking to.
Right.
But you can actually validate at compile time with static types that your communication is correct. That your communication, you can actually validate at compile time that it's going to work. that communication is
and is that because the IDL is generated?
Because the shared IDL.
Okay.
It's because you've shared a contract, the IDL in this case, between the two.
Right. And so if I'm doing it in Kotlin, now the Kotlin compiler is going to make sure that generated...
Yeah, you can't access a property that
right.
doesn't exist.
Right.
And so I think that there's something interesting about bringing together this dynamic static. Maybe it's not about bringing together dynamic and static. Maybe it's about giving you the benefits of dynamic by sharing an IDL in a way that you get the actual the value of static typing against that. And so what I haven't really seen much of yet is taking this beyond just using this shared IDL for serialization and deserialization. Essentially, that's all that it's doing. That's all. So, like when you in gRPC, I guess it's not just. Is it just serialization? It's operations and serialization. So with gRPC, it adds the concept of you also define your operations on
because I'm making a RPC,
well.
a remote procedural call.
Exactly.
Oh, right. Yeah.
Yeah. And so I guess you're not just getting serialization. You're getting you're also able to get the operations on that IDL verified with static types. So, but what I haven't seen yet is taking this beyond operations and data to something like queries. So queries are, you can create a SQL query that does anything, and you don't know if that's valid until you actually run it against the current set of data. So I wonder if we can take this to some the shared IDL construct to other areas that would allow us to have more static validation for things beyond just operations and data.
Yeah, but it doesn't test behavior, which is what you're talking about. Yeah. See, maybe that's our problem, is expecting static type checking to validate behavior, which it can't do.
Yeah, that's true.
Whereas if it's dynamic, I think, so
an example of this would be, let's say that I call a gRPC endpoint with some data. I can validate that my data structure was correct. I can validate that I'm calling the operation correctly. But what I can't validate is that I can expect a certain result to come out of that operation call. So, for example, I've with some services there can be weird behaviors, like I call this endpoint, I give it some data, I create an object, and then if I immediately after I create that thing try to make another call to, I don't know, do something else with that object, the system will be like, I don't know about that object, because of eventual consistency or whatever it may be.
There's some sort of state thing
exactly.
happening. Yeah.
So I've just hit some kind of race condition. And so that's absolutely something that is totally valid from the data and operation perspective, but from the behavior perspective, I've not been able to validate with my type system.
Yeah, the design by contract stuff is like an attempt to make that more reliable by saying, okay, validate preconditions, do the thing, check post conditions. But it's still, within that function, okay, that helps. But yeah, I think we're just trying to do something that we're looking at the problem wrong. We need to look at it as maybe the applied math versus pure math, saying, okay, yeah, here are things we can validate and we should do that. But then there's this line we cross, and then we're into this world of, we don't know if that model works, and, but maybe just acknowledging it, because then it's like, okay, we only want to take our static type checking so far.
Right.
And then we want to actually add a bunch, rather than saying, we have to be able to statically type check everything, and then that will fix all of our problems.
Yeah.
Finding that line where we're going, now it's beyond, it's making life a lot harder. And what we should really do is add a bunch of stuff in the dynamic area to help us
Yeah.
be able to validate our systems.
Yeah. Yeah. So John didn't go into as much detail as I would have liked on how Scala 3 is addressing some of this to make it easier, better, whatever. I think I think there's a few pieces that are making it a little bit better in Scala 3, but I think generally the core problem still exists. So I think GADTs are one of the ways that makes it at least easier to.
Should probably spell that out just in case.
Is it general algebraic data types? Generalized. Okay. I may be getting that wrong. I don't know much about GADTs, but it's a way to do type class derivation. So you and I have been diving into type classes lately, and as we've been working with type classes, we are writing the type classes that do a conversion from a type A to a type B, and we have to manually implement that. And so what GADTs enable type class derivation to do is for the compiler to create the type class for you. So now you get the adapter from your type. So I think it's not really addressing the underlying problem of I want to make this thing static, and I don't know if it's actually going to work until I actually run it against the production system. I don't think it's actually dealing with that problem. What it's saying is we're just going to make it a lot easier for you to do the static typing stuff. And you're going to be able to generate these things, and you're still going to have to validate them against your system, or things could actually go wrong, when you run this thing against a real system. But they're not solving that problem, but they are making it easier to deal with the static typing, maybe overhead complexity that you as the developer would normally have to write to interact with those external systems.
I like easier when applied to language features.
Yeah.
Make it easier for you. That's music to my ears.
Yeah. So an example of this is that in Scala 2, if you want to generate SQL statements from your static code, or you want to generate JSON deserializers from your static code, the way that this is typically done in Scala 2 is that you have to either as a developer write those mappers manually, or you use a macro to generate those wrappers for you. And so with Scala 3, we'll be able to have the compiler generate those wrappers, but not via a macro, which can be a little black boxy, scary, magical. And so now with GADTs, those generators become much more well-formed and part of the core machinery of the language.
But just to be clear, Scala 3 still does have some kind of macros. They're just easier to understand or something. Is that?
We'll have to ask Josh Surratt for more details on this, because he's a real expert on this front. But my understanding is that they for backwards compatibility, they still have the basic macro system, which is taking strings essentially and injecting them into the compile process. I mean, that's what macros are essentially doing for the most part. And so they still have that, but they've created some higher level abstractions that accomplish a lot of the same things that macros are doing, but they've done it in a way that is not so freeform, scary. They've done it in a way where the compiler understands what's happening. The compiler is giving you the right places to hook in to the compile process.
And it's actually using Scala syntax, right?
Yeah. Yeah,
Okay,
yeah.
which is much nicer than saying, "Oh, we're doing macros. Now we're switching to a different
That's
language."
exactly,
Hmm.
exactly.
So
There
that's
there has
promising.
been a way to use Scala syntax to write Scala macros,
Hmm.
but it was a bit of a hacky workaround.
Hmm. Hmm.
So GADTs are one of the new ways that accomplishes the same thing as macros, but do it in a much safer way.
Hmm.
And in a so one of the key things that Scala 3 has really been founded on is trying to have a provably correct type system. And it turns out when you have macros, you lose the ability to prove that your static types are correct. And so macros were off the table for being able to be part of like that
Hmm.
dot calculus verifier of the static typing. Um, but they needed some way to accomplish the same things, and so they've created a number of higher level abstractions that give you the type soundness without having to drop down to macros. So another one is we talked a little bit about you and I this week, which was the match types, which are another way to do compile time metaprogramming, but do it in a type sound way.
Hmm. Hmm.
So yeah, so I think maybe there's a couple different avenues of exploration that are happening here. Like I think we've got this whole spectrum of what we can do. You can just be like, well, I can't verify it, and so dynamic typing is great and works for me. Or you can be like me and be like, all right, I don't care if I can't verify it at compile time. I'm still going to use static typing, and I would much rather write a flat map to do a join on a data set than you do an actual SQL join, because I can never remember if I should do an inner join, an outer join, a whatever join. Uh, and so when I write SQL, essentially, I do a flat map. And to me that just feels so much better. But I'm a Scala programmer, not a SQL person. And so there's that side of the spectrum. And then I think there's the like shared IDL gRPC, which says, all right, maybe we can have the static types by sharing a definition across our systems. So I think that's one approach. And then I think uh, on the Scala 3 side says, all right, we're still not going to be able to validate that this thing works until you actually run it, but maybe we can just make dealing with the static typing around this stuff easier with GADTs and some of the other Scala 3 features. So
I think I've finally kind of come to the conclusion that my issue with static typing, and I'm sure a lot of it had to do with Java, was that you would go through all of this ceremony, and a lot of it, because of the Java syntax, was way more painful
yeah,
than it had to be.
yeah,
So, and then when you go to Kotlin, you go, oh, this isn't so bad. It's straightforward. It's understandable. I can read it and everything. But in Java, there was all this kind of Sturm und Drang around it, and then you'd still have stuff
that didn't
failing
work.
at
Yeah,
runtime,
yeah,
and it's like, okay, if I'm gonna have stuff fail at runtime,
why did I go
why
through
did
all of
I
them?
have to go through all this struggle
Yeah,
to satisfy the compiler? And I think when I work with languages where, first of all, the syntax is a lot cleaner, like Kotlin, and um, then I can see it as, oh, it's doing as much as possible for me, but it isn't putting me through all of that pain to
yeah,
make it fit its. Yeah, and I mean, sure, there's still going to be failures at runtime, but it's helping.
yeah,
It's helping. It's not arbitrarily forcing me to jump through a bunch of loops. I don't have to repeat my. That was one of the things that I've come up. I just realized with Java, it's like, oh yeah, with the new var syntax, so it's it can do type inference. Once again, well, it works most of the time, except a few cases where it doesn't.
yeah,
We were discussing this earlier. It's the pain of all of those special cases that you either have to remember or you just stumble across and go, wait a minute, why doesn't this work in this case?
yeah,
It's not, it doesn't have that consistency that makes it easy to move forward
Yeah.
when you're programming.
Yeah.
It's like, yeah, sure, lambdas are. I'd much rather have lambdas in Java than not, but then there are these special cases where they don't work,
Yeah.
or they don't work the way I would expect them to, and then I have to go, did I misunderstand this, or oh no, it's a special case, and I have to deal with that special case. It's like at some point, and this is why I was calling it the Java, the death of a thousand cuts.
Yeah.
It's like all of these little things build up, and at some point you go, yeah, it's nice to have these new features, but they all have their little special case costs that I have to deal with. And I should either not use the new features at all, just be Java programmer, old style Java programmer.
Yeah.
And then if I start just adopting these new features one at a time and deal with all of their little special cases, and the code that I write is going to look to people like, why did you do that? Oh, well, I had to.
Yeah.
But it's not obvious when you're reading the code. It's like, at some point, you should just say, oh, if we're going to start having new features, like important new features, we should just switch to Kotlin.
Yeah. 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 I think when I go back and write Java, I feel those little cuts, and
Mm-hmm.
just one cut isn't so bad. It's like, oh, okay, I guess I'll deal with primitives. Like, I don't want to deal with primitives, and I'm so glad that in most modern languages I don't have to deal with that. So it just is like one little cut, but then another one comes, like, oh, lack of type inference. Oh man, that's like just a pain. Really, I got to specify these types, and then it just accumulates and accumulates to the point
Mm-hmm.
where now I have a hard time writing Java, and I think it just is painful, and I think that now I'm very sensitive to all those little cuts that I get when I'm writing Java.
Yeah, it is. Although my experience was that, okay, it took me about, I don't know, a couple of weeks after going from the Kotlin book back to updating the on Java 8 book. It took a couple of weeks before I kind of settled into it and kind of remember, okay, this is the world I'm in, and I'm not constantly going, why is it, why didn't they do it right? And then it's okay, but I'm still aware that I had that transition. And I'm also much more aware, I've had this with learning new languages. I'm aware that the working on Kotlin has influenced the way that I think about Java. And I think I write better Java code. It's like there are things where I'm going, oh, well, yeah, I should traditionally, I'm rewriting this code, and I had some sort of private variable which doesn't really need to change, and then had a method to expose the variable. And I go, well, why not just make it final,
Right.
and then just have some, and it's like, that's not the Java way.
Yeah. Well, yeah, and maybe we experience more cuts as we try to like shoehorn a paradigm into the language that it wasn't really meant for. So where I experience a lot of these little cuts when I go back to Java is around immutability. And I'm, totally try to make everything as immutable as possible, as we've talked about many times. But when I try to do that in Java, oh, it hurts. Like the fact that that it's not an expression oriented language makes it really hard to do immutable things. So I ended up in some of my Java code, because if else isn't an expression in Java, I ended up using the what's a ternary syntax, which just looks terrible and gets really unwieldy, and it definitely feels like, okay, I'm pushing against what the language was designed for, and I'm getting cut as a result of that. And if I would just throw my hands up and be like, okay, I'm not going to try to write Java code like I write Kotlin or Scala code, then I probably wouldn't get cut so much.
I guess so, but there's still, the benefits, like in this case, I'm looking at things, I'm going, oh, well, this is really a messenger/data transfer object. I wasn't thinking about that when I was writing it, but now I look at it, it is. So I should make the fields final, initialize them, in the constructor, and then it just, and you see the benefits of doing that. Yeah. And
Yeah.
But then somebody might come along and read it and go, why aren't you using the standard Java idioms for this thing? You know,
Yeah.
we the bean,
Yeah.
ugh,
Yeah.
we're not going to have properties because that's dumb. I don't know why, you know, maybe they'll add them in Java. What would it be? Java 23 or something, the next long-term release. They finally go, oh yeah, we see from Kotlin that properties are actually a pretty useful thing to have.
Yeah.
So we'll put them in. And then of course those will have the little compromises that they have to put in that you have to remember. I don't know.
Yeah.
I think my recommendation is stick with the Java that you have now until you're forced to move to the next long-term release. Don't change your code as much as you can. But if you want to do anything beyond that, change languages, man. Go switch to Kotlin.
Yeah, I think to your point, once you've received enough of those little cuts,
Mm-hmm.
it's good motivation to move forward to a different, more modern language
But
that
how do
doesn't
you?
have all the baggage. Because I think, like you're saying, like even if you do start adopting the brand new features of Java, which there's some nice things there, you still have a lot of sharp objects to get cut on because they've had to add these language features in at the cost of something. And so, even if you're trying to adopt the new Java stuff, it may just be easier to switch to.
Oh, I think it is. I mean, the question is, how is that? Um, how do you convey that to the people who make that decision? You know, it's like, oh, we have all these little annoyances. Programmers are always complaining about things.
Yeah.
Just suck it up and deal. You know, just we don't want to change from Java. It would cost too much, and you're thinking, no, it actually would cost more not to. It's going to be hard. I mean, maybe some kind of studies or something would do the trick. I don't know, but it's a.
I think a good example of this is the Java Stream API stuff,
Mm-hmm.
because I want the functional stuff on all my collections.
Mm-hmm.
And in the world of Java, it's great that they added that, but it's painful to use because you have to transform most of your code is dealing with non-stream collections.
Mm-hmm.
And so then you have to transform into a stream. And then once you've transformed into the stream and do your operations, then you have to transform back into the like base collection. Oftentimes you have to do that like collect and then collections to list or whatever it is. And it's just like it's nice that the stream API exists, but there's a lot of cuts that you don't feel when you're doing the functional transformations on collections in Kotlin or Scala.
Right. It's another one of those things where it would have been nice. Well, generics is the greatest example because when it's been added to an existing language, there's always that compromise that gets made.
Yep. Yep.
With all of this, I have already found myself thinking, oh, I'm gonna rewrite on Java 8 for Java 17 or whatever. I'm gonna try and make it as I'd like that to be the last Java book that I write, but I'm actually intrigued just to see, how is this going to look different now that we have records and whatever their pattern matching is going to look like. And there's going to be compromises there. It's not going to be like,
that's right.
I mean, because the switch statement, they added strings.
Yeah.
Woohoo. I mean, I know people use strings a lot, but it's like, it's not really a generic. So anyway, I am, and the VARs and all that kind of stuff. And I'm going, I would like that to be the end point and, rewrite it somehow and do it right, quote unquote, right.
Yeah.
I can't see myself not doing that just because I'm intrigued now, but
if you roll forward the clock, let's say 5 years from now,
mm-hmm.
What percentage of the Java community do you think will have adopted the new Java language features or switched to a new language or just stuck with, the syntax that we have today?
Yeah, I feel like the people who are interested in new features are going to see that they're going to see the awkwardness of trying to adopt the Java way of doing it versus switching to Kotlin. They might not have the power to get their company to switch.
Yeah.
And so, I don't know. That's going to be a mess because there are going to be a lot of people who aren't interested in, I'm a Java programmer. I'm program Java this way. These new features, they take time to understand and acquire. It's a different way of thinking about the problem. And there's, all these, I just don't want to do it. And then there are the people who go, I can't, I have to. And those people, maybe they'll end up just changing jobs to somebody's running Kotlin or Scala. And then there's percentages and then there's numbers. Because it's like, even if, what do you say?
2 million Java developers stick with the
that's still 2 million Java developers. And maybe that's only, 20% of the Java developers or whatever out there. The rest of them move on, but that's still, that's still a lot of people.
And I guess if you're Brian Getz and the folks at Oracle, maybe you know that you're not going to keep 100% of the people on Java, but you're still potentially talking about millions of developers that are going to move forward with you. And that's, I'm sure, good motivation to keep innovating and keep doing great things in the language.
Oh, speaking of cuts, you told me a story about your Perl guide. Tell the story about your Perl guide.
Yeah. So we were talking about quirks in languages,
yes,
which is very related to this concept of these little cuts. And I was telling you about how in Perl.
How long ago was this?
This was 98. So what is that? Over 20 years ago. Oh man,
it is. You're old, man.
Yeah.
You have gray hair.
That's right. So Perl has so many quirks, and I just can't keep all of them in my head. And so I was building e-commerce systems in Perl. And
because that's what you did back in 98. I tried doing it in C, so I got stuck.
So there's so many quirks in Perl that I could not keep in my head. I had the O'Reilly Perl Quick Reference book, which was a tiny little, 3x5 in very thin book that was just, the very minimal. But it was enough where it would give you the quirks that you needed to be able to look up quickly. And so as I was programming in Perl and encountering these quirks often, I needed that quick reference book so handy that I would literally put the book in my teeth and hold on to it with my teeth so that I could type and then quickly, very quickly pull up the quick reference book out of my teeth and look something up and then put it back in my teeth and keep typing. So it just was, that close at hand. I needed it so often. So now maybe this has driven a lot of my goals in programming is to gravitate towards things that don't have so many quirks and don't require a quick reference book that at hand. So
you don't have, it's the special cases. Like what you'd really like is this kind of consistent flow. And I mean, that's what I always loved about Python is like, it just seemed really straightforward to me. And then I wasn't going, oh no, it's going to be, different or special or whatever. So
I guess I have gravitated away from the things that require me to hold a quick reference book in my teeth.
You mean, well, I mean, as far as I know, you've never done that since Perl. So
I haven't done that since Perl, but now with Stack Overflow, I very often use Stack Overflow almost in the same way as holding that book in my teeth.
As do we all.
But there are languages and technologies that I am much more Stack Overflow centric to than others.
Sure.
So Bash, oh God, I guess I haven't gravitated totally away from things that are very quirky because I've written a lot of Bash lately.
Oh, really?
And Bash is one of those things where I am on Stack Overflow like every 30 seconds.
I have, I've written Bash shell scripts, but it's never made sense to me it would be so nice because it's just right there. You don't have to get people to load anything or any,
the universalness of it is nice.
And so what I end up doing is if I'm going to do anything more than just a few lines of bash, I go, okay, I'm going to use Python because it allows me to do everything I need to do. And I don't have to learn this weird, arcane syntax, which I've never internalized that. Well, I was surprised that we were able to do this topic for the entire time. But one of the things I'd like to put out there is if people have topics, I mean, there's no guarantee that we'll, cover them, but if they have topics that they'd like us to cover or people they think we should interview, please put that on the Discord channel. And then we can, have more possible things to look at.
Yes.
So.
Yeah, and we do need to get some guests on. We need to send some emails. After my discussion with Roman from JetBrains yesterday, we got to get him on.
Oh yeah, he might be beyond our brain capacity to keep up with, but we can always ask him questions.
We got to get somebody from Unison on.
Mm-hmm. Oh yeah, that would be interesting. Yeah, some of these topics that we're fascinated with, we can use the podcast as an excuse to talk to interesting people.
Well, that's what we do on every episode is we talk to interesting people.
Yes.
I find you interesting.
Yeah, I find you interesting too.
Thanks.
We should expand our echo chamber though.
Yes, we should.
Okay.
All right. Well, thanks.
Once again, it was fun.